So, in continuation to our previous class, we have 10 more problems to cover. Right. Man of mass m moves on a plank of mass m with a constant velocity u with respect to the plank as shown in the figure. See, he's moving with the constant velocity. Constant velocity, and then if the situation given to you is if the plank rests on a smooth horizontal surface, determine the velocity of the plank. That is okay, fine. Already we know one relation. What is that? Displacement of the plank is equal to minus a small m by capital M plus small m times displacement of the man with respect to plank. So you will differentiate this, which allows you the velocity of the plank is minus a small m by capital M plus small m times. What do you need to write? Velocity of the man with respect to plank. ఇక్కడ వీడు ఇచ్చింది కూడా అదే కదా. So therefore Vp is small m by capital M plus small m times u leftward. So half of the question I have done. Half of the question I have done. The man travels a distance L with respect to the plank. Fine. Right. The man travels a distance L with respect to the plank. Find the distance. Same question it seems. It is a repeated question. Already I have answered here. Same. Which means already I have answered. Displacement of the plank is m by capital M plus small m times L leftwards. I think it is done. Repeated question. Okay. Now, next question. Already we have done this question, the theory part of this question, but still I just want to highlight this thing. And in this case, we will call this distance as, I know how to do x1. This distance is x2 and this distance is x3. I know already about this x1 plus x2 plus x3 is nothing but this is L by 2, this is L by 4, and this is L by 6. I have given the sufficient theory for this. So therefore, in the denominator, you will have 24, 12 plus 6 plus 4, 22 by 24L, which is nothing but 11 by 12L. That is 57. Any doubts? Very easy substitution model. Right. Right. We will work on this theory question now. It's a theory question only, hardly. Right. A man is standing on a plank which is placed on a smooth horizontal surface. There is sufficient friction between feet of the man and the plank. Now the man starts running over plank. See, already we have done this question, frankly speaking. Already we have done this question. Now see, you are running. Yesterday only we have done this question, a similar type of question. Do you remember? This is a plank. Fortunately, smooth horizontal surface. See, what makes the man to move forward? There should be some friction that acts in the forward direction, and the counter on the plank is in the backward direction. Right. Now the man starts running over the plank. Work done by friction on man with respect to ground. Work done by friction on man is correct statements. Is or is what they're asking. On a smooth surface, there is sufficient friction between the feet of the right. Now the question is, lot of students will feel that, sir, you are a bit confused how one is correct. Remember, this is the contact point of a man on plank. Agreed? Now see, F on man is positive X direction. Okay, motion of contact point. What is the direction of motion of contact point? Is in negative X direction. So therefore, work done by friction on man with respect to ground is negative. Next, work done by friction on man with respect to, see, when you accepted 1, you cannot accept 2, right? Work done by, yeah, obviously when network is 0, this is negative, this should be positive. Work done by friction on man with respect to plank is 0. Why? There is no slipping. Because there is no slipping. So, because there is no slipping, work done by friction on man with respect to plank is 0. Because with respect to me, the contact point is not moving at all. Right. Chalo. Next. Is this clear? Next question. Already we have done this question, but still. Block of mass M moving with a velocity V0 collides with a stationary block of mass M to which a spring of stiffness constant K is attached as shown in the figure. Choose the correct alternatives. First of all, what is the velocity of, see, honestly, initially velocity of the center of mass is mv0 plus 0 by small m plus capital M. mv0 by small m plus capital M. Any doubts? Right. That is the velocity of the center of mass. The initial kinetic energy of the system in the center of mass reference frame. The initial kinetic energy of the system in the center of mass reference frame. Or here, we know half reduced mass times V relative square. You already know this. So half small m capital M by small m plus capital M V0 square. So therefore, when observed this particular thing, first one is wrong, second one is wrong. Antega? Next. The maximum compression in the spring is apply law of conservation of energy. Apply law of conservation of energy in C frame of reference. C frame of reference. Now, half small m capital M by small m plus capital M V0 square is the total energy initially. Finally, the entire energy is F kx maximum square. And why you are not writing kinetic energy term in C frame? Because at the instant of maximum kinetic energy, what happens? Both the blocks move together the same velocity. The relative velocity is 0. So therefore, I've done. X max is clearly under root small m capital M by capital M plus small m times K into V naught. Right. When the spring is, third option correct. When the spring is in the state of maximum compression, the kinetic energy in this, correct. Right. Easy question. Because that we have done that much a number of problems, today you see in less time we have solved 4 questions. Right. Now let us shift this up. A long plank A is at rest on a smooth horizontal surface. Right. Small block B, whose mass is half of A, is placed on the plank and at one end and projected along A with some velocity U. Coefficient of friction between the plank and the block is mu. Fortunately, this is smooth. Now, what will happen? I will explain clearly. See, they will attain some common velocity. Why? Because see what is happening over here. B, you have projected in this direction. B will experience a frictional force. Similarly, A will experience a frictional force and it starts to move. So when both attains common velocity, what happens? F becomes 0. So therefore, what is common velocity? You can apply law of conservation of linear momentum also in this. Because mv is initial, small m plus capital M, actually velocity of center of mass is also the same. So therefore, the common velocity and center of mass velocity is the same here in this case. That's the deal. So, and any information, it was also given that a small block B whose mass is small m is given as capital M by 2. Given. If you substitute this, capital M by 2 by 3 capital M by 2 times V. So it will be V by 3. So therefore, first option is correct. 17. V is now. What is happening over here? Kinetic energy initial of B is a half m by 2 v square. Kinetic energy finally of B is half m by 2 v square by 9. So change in kinetic energy of B is minus 8 by 9, because this minus this kada. 8 by 9 times half times m by 2 v square. Okay. Similarly, kinetic energy initially of A, 0. Kinetic energy finally of A is half into m into v square by 9. See, please try to understand this is nothing but minus 4 by 9 times half mv square. This is simply 1 by 9 times 1 by 9 times half mv square. Now, what is the second option? Work done against friction is 2/3. Now, what is the work done against friction? Work done against friction is 2/3 of the initial kinetic energy of the block. Now, what is the work done by friction on B? This is minus 4 by 9 times half mv square. Agreed? Work done by friction on A is plus 1 by 9 times half mv square. So what is the net work done by friction? The net work done by friction is minus 1 by 3. Sum of this is half mv square. Of course, net work is negative because there is slipping. And the nature of friction involved is, what is the nature of the friction involved in this? Say, స్టాటిక్ అయితే అసలు జీరో కదా, నెగిటివ్ వచ్చింది వైబ్రేషన్ మీకు. కైనెటిక్ అయితేనే నెగిటివ్ వస్తుంది, స్టాటిక్ అయితే జీరో వస్తుంది, స్లిప్పింగే ఉండదుగా. ఇప్పుడు ఎందుకు ఏం చెప్పాలి? ఇప్పుడు సెకండ్ ఓకేనా కాదా? వర్క్ డన్ అగైనెస్ట్ ఫ్రిక్షన్ ఈజ్ 2/3 ఆఫ్ ద ఇనీషియల్ కైనెటిక్ ఎనర్జీ. ఈజ్ 2/3 ఆఫ్ సెకండ్ క్వశ్చన్ ఏంటి? ది వర్క్ డన్ అగైనెస్ట్ ఫ్రిక్షన్ ఈజ్ 2/3 ఆఫ్ ద ఇనీషియల్ కైనెటిక్ ఎనర్జీ ఆఫ్ ద బ్లాక్ కాదు కదా? యా కరెక్టే, ఎలానా చెప్తాను నేను. హలో, కరెక్టే. ఇది minus 1 by 3 కాదు, ఇది 2 by 3 టైమ్స్, కంగారు పడకండి, m by 2 times v square. This is the kinetic energy initial of block B. Correct or not? Work done by friction. Against friction ante, this is by friction. This is work done by friction. But against friction ante plus 2 by 3 times the kinetic energy initial of B. 2 is correct. Before the block and plank reaches a common velocity, the acceleration of A relative to B is. Good question. Remember, this is B, and now this is experiencing a frictional force of mu m by 2g. Okay. And this causes it an acceleration AB given by mu g. Agreed? On A, the lower one. Mu g by 2. They are in opposite directions actually. So A relative is acceleration of A plus acceleration of B. This is mu g plus mu g by 2. కరెక్టేనా? నేను రాస్తాను, చూడండి ఒకసారి. So this is nothing but 3 mu g by 2. So 4 is correct. 4 is correct. 3 is wrong. Any doubts? Clear? Dura letende. Any doubts? Are we clear on this, Pakka? Sure? Next. Two blocks of mass M1 and M2 are connected by a spring in its natural length, having spring constants K and are placed on a smooth surface. Block M1 and M2 are given velocities V1 and V2 as shown in the figure. Choose the correct statements. దీనిలోనే ఫోర్స్ అప్లై చేసే కేసు కూడా ఒకటి ఉండాలి. Okay, I'll just see that. Right. Now what is happening over here? See here, all are smooth. First observation, no external force acting on the system. Okay. Since there is no external force acting on the system, momentum is conserved. Momentum of the system of mass M1 and M2 in the frame attached to the center area are already one of the characteristics of center of mass. What is the one of the characteristics of center of mass? In C frame, momentum of the system is always zero. Characteristics of center of mass. In C frame, the algebraic, already I have written this. Do you remember it or not? VIC is 0. So therefore, 2 is correct. And number 2, this term is always constant. Why? Because velocity of center of mass is always a constant since there is no external force. So therefore, half M1 plus M2 times VCM square is always a constant. How long this constant is allowed since there is no external force? Right. So therefore, I can go with the 3. Kinetic energy in center of mass frame remains constant. Wrong. Why? I will explain. Kinetic energy in the ground frame is half mu V relative square plus half M1 plus M2 VCM square. Okay. This is Ke ground. So total energy is half Kx square plus half mu V relative square plus half M1 plus M2 times VCM square is constant. I said sum of 3 terms is constant. But remember, as this one changes, this one changes. As X changes, V relative changes. So therefore, kinetic energy in center of mass of the frame remains constant is wrong. In fact, this is the kinetic energy in C frame. As V relative changes, Ke in C frame changes. Any doubts? Are we clear? Am I running fast? Right. అరే ఇది రిపీటెడ్ క్వశ్చనే బట్ స్టిల్ ఓకే చూడండి ఒకసారి. Go through the question and try to answer. Too many A and B, mass 50 kg. Are done this question n number of times. The length of the plank is 5 and is kept as the man starts moving and extend the area. Come on. Only thing, I'll just write the condition. We have already done this actually. Mass of A, displacement of A with respect to plank plus displacement of the plank plus mass of B, displacement of B with respect to Planck plus displacement of the Planck plus mass of C, displacement of the Planck or mass of Planck, displacement of the Planck is equal to 0. Just do that, you will get 2 and 3 as answers for this. I repeated question actually. Next. Yes, 24th question. 34th question. A car A of mass m is initially at rest on a plank of mass m tied to the identical plank C of same mass capital M through a massless inextensible string as shown in the figure. The car accelerates from rest to V0 with respect to plank B in time t0 seconds. At time t is equal to t0 seconds, the car applies brakes and comes to rest relative to the plank in negligible time. Very important model and difficult question. One of the most difficult question in this week. Try to please understand what is happening during the state of acceleration. During the state of acceleration, car, this will experience a frictional force F in the forward direction. Okay, right. And whereas as a, no, see, actually, this one will experience frictional force in this direction. Remember, both will move with the same velocity during that time because they were connected. Right. Now, at t is equal to t naught, let this is moving with velocity v naught. Okay, rightwards, v naught, rightwards. Which one? Car. And whereas B and C is moving leftwards. As I right or not? Because they were connected. Actually, they were connected. In game మరి అన్న ఆన్సర్స్ ఉండేవండి ఒకసారి నన్ను అన్ని వీనాట్ టర్మ్స్ లోనే ఉన్నాయి. This is a left. We will take this as a VP. And you can take this as a whole as one single system actually. Yeah, as a whole as one single system. So you can apply, in fact, momentum impulse theorem also. F into T is small m V naught because it starts from rest. 0. Similarly, on this F into T is capital M plus capital M times VB. Let this be equation 1 because initially both are starting from rest. Are LHS same or HS same? So finally what I can write is M V naught is equal to 2 capital M VB. Right. When the car A reaches to velocity V naught with respect to the array, come on. V naught is with respect to the Planck. We'll call this as VA. VA. In that case, this is like a Planck. This problem can be consolidated to a Planck of mass 2 capital M and a man of mass small m. So in that case, velocity of Planck is small m by small m plus 2 capital M, velocity of the man with respect to Planck, because you said it is V naught with respect to Planck. Done? Any doubt in this? Ask me right now. Any doubt in this? If this is the case, what is the velocity of the man? The other part, 2m by small m plus 2m times V naught. Actually, this is with respect to ground. This is with respect to ground. And in fact, I should write a minus sign and I should write a plus sign. Plus sign indicates rightwards. Minus sign indicates leftwards. So therefore, for 24th question, when the car reaches to velocity V naught with respect to the Planck B, the velocity of the car. You want the velocity of the car. Car means the upper part. Right. When the car area, when one is correct, two is wrong. అవును రా విత్ రెస్పెక్ట్ టు ప్లాంకే నేను రాస్తుంటే ఎక్కడ ఎక్కడ తీసుకున్నావు అంటావు ఎక్కడెక్కడ చేస్తా అదే చెప్పు నువ్వు ఒకసారి లేదు ఇదేంటిది వాట్ ఈస్ దిస్ టర్మ్ ఫార్ములా గుర్తు తెచ్చుకో velocity of the Planck is minus small m by small m plus capital M times velocity of the man with respect to Planck. Similarly, velocity of the man is plus capital M by capital M plus small m times velocity of the man with respect to Planck. ఈ ఫార్ములాస్ గుర్తున్నాయా గుర్తులేదా నీకు చెప్పు అసలు అవే కదా నేను అప్లై చేసింది. What else I have applied apart from this? Tell me. Just applied the same. Yeah, Varun, ఇప్పుడు అడుగు నన్ను. Man means car here. In the place of capital M, what I should write? Two planks together moving. 2M. That's what I have written. ఎక్కడెక్కడ రాశాను? B with respect to ground. ఇప్పుడు ఇదేంటిది? What is this? With respect to ground. What is this? With respect to ground. Question జాగ్రత్తగా చదువు. When the car A reaches to velocity V naught with respect to the Planck, comma ఉంది ఇక్కడ. The velocity of the car is with respect to ground. ఇప్పుడు ఓకేనా? ఏం చెప్పకపోతే దట్ ఈస్ విత్ రెస్పెక్ట్ టు గ్రౌండ్. ఓకేనా? ఏం చెప్పకపోతే విత్ రెస్పెక్ట్ టు గ్రౌండ్. అదే కదా నీ కన్ఫ్యూజన్. ఇప్పుడు నీకు ఓకేనా? ఆప్షన్ 1. రైట్. నెక్స్ట్ థర్డ్ ఆప్షన్. థర్డ్ ఆప్షన్ వచ్చేసి ఏంటి? వెలాసిటీ ఆఫ్ ద ప్లాంక్ బి జస్ట్ ఆఫ్టర్ అప్లయింగ్ ద బ్రేక్ ఈస్. ఇక్కడ ఐ డోంట్ థింక్ ఫస్ట్ పార్ట్, ఫస్ట్ 2 ఆప్షన్స్ ఈజ్ నాట్ ఎ డిఫికల్ట్ టాస్క్ ఫర్ యూ. Now, what is the biggest task for you? What is the biggest task for you is, handling the second part. Anika, first part clear? Pakka? Right. After the car applying or after applying brakes to come to rest. Important point. Color change. after applying brakes to the car. Right. Remember, now you are applying. See, okay. Again, I'm drawing the free body diagrams again. Now, friction acts in this direction. On the plank, friction becomes forwards. Yes or no? Previously, it is backward. This is the, in fact, at that time, this is the direction of motion. At that time, this is the direction of motion. Now, what happens here? Tension becomes zero. Why? Now there is no acceleration for this. In fact, this is having a rightward acceleration. Now see, how can it happen that this end of the string has a rightward acceleration, this end of the string has a leftward velocity? No. What happens in that case? It will become loose. Tension becomes zero. How many have understood this? Raise your hands. That's all. Question is done. Yep, you know you apply law of conservation. Now you apply law of conservation of a linear momentum. Apply law of conservation of linear momentum to the system A and C, whatever it is. Now you apply law of conservation of linear momentum. You said somewhere you are coming to rest also. Somewhere you are coming to rest also. At time t is equal to t naught, the car applies brakes and comes to rest relative to the plank in negligible time. No time. Suddenly it happened. Suddenly. So in this case, for this system, apply law of conservation of linear momentum. Just before, what is the situation? M times VA rightwards minus M times VB. I already taken magnitude here. This is, and finally both will move together. Antega? Hello? Both will move together, kadra? Yes. Came to rest with respect to plank. V common. Right. Any doubt? Now, MVA, this will become 2 capital M small m V naught by 2 capital M plus small m minus MVB. మీరు అంతా చేసే మిస్టేక్ నేను చెప్తాను. మీరు మళ్ళా మైనస్ వేయకండి, ఇది మ్యాగ్నిట్యూడ్ వేసేసండి. Right. This is a 2 capital M plus small m. Don't put minus again. Already I took minus sign means I know I'm prepared that it is moving leftwards. And V naught. And this is equal to capital M plus small m V common. Which implies V common is equal to, boys and girls, capital M small m by V naught divided by 2 capital M plus small m times capital M plus small m. So that's all. So you should go with 3. Option 3. When 3 is correct, 4 is wrong. Any doubt in this? Right. This is a very good question. Now you should take this as your system. This is our system. You may ask me why? Because tension is 0. Now it has nothing to do with the right side block C. You have nothing to do with C. Now, what is your system means? It is A and B only. Because tension is 0. Any doubt? As a whole, just go through once. Any doubt? Anywhere, any step. Boys and girls. Pakka. Right. Go for this question. చాలా simple question. Massless spring of force constant 1000 Newton per meter is compressed at a distance 20 centimeter between discs of 8 kg and 2 kg. Spring is not attached to discs. The system is given some initial velocity 3 meter per second perpendicular to the length of the spring as shown in the figure. What is ground frame velocity of 2 kg block when the spring regains its natural length? Remember, momentum is all the time. See, remember, I know that this is a maybe next week topic, but still border. So therefore, linear momentum is conserved in this system because there is no external force acting on the system. No external force acting on the system. Right. Right. Now sigma Py0. Okay. Y means along the spring. Along the length of a spring. I am assuming when spring regains natural length, let us assume this is Vay. Remember, the entire arrangement is on a horizontal table. Don't feel that it is vertical. This is Vby. Yes or no? So in the this is the picture what you have. Right. Remember the 3 meter per second velocity is all the time available. Now I am doing the problem in this frame. In a frame moving with 3 meter per second. You will see only this. Now apply law of conservation of energy. One more important point, linear momentum is conserved in that direction. 2 times Vay is 8 times Vby. 4. Yes or no? Any doubts? Right. Now I apply conservation of energy. Half times 2. There I am doing the problem in this frame. 2 Vay square plus half times 8 Vby square. Antega energy is all this is energy stored in the spring. Okay, ఒక నిమిషం ఆగండి నన్ను. 4 and Vay can be written as 4 Vby. 16 Vby square plus 4 Vby square is half into what is K, by the way, K 1000. Compressed amount 20 and 1/5. కరెక్టేగా? అరే 20 సెంటీమీటర్స్ మీద 1/5 మీటర్. 40, 20, which clearly implies VBY is equal to 1. అంతేగా? If VBY is equal to 1, VAY is equal to 4. But this is not the answer. So with in a ground frame, color change. So for A, you have VAY 3 meter per second. For B, you have 1 VBY 3 meter per second with respect to ground frame. What do you want to find? Velocity of 2 kg block ante A. VAY is 4. So obviously the answer will be VA is VAY square plus 3 square. So this is nothing but 5 meter per second. Any doubts? Pakka? Sure? Last student. అరే నూరా బోర్డు అదే ఫాలో అయినట్టేనా? పక్కా. రైట్. అరే I think this is okay, fine. But anyway, do this. Do this. Where is my phone? I need to do one more question. Let me just. You have a situation here. Too many A and B are right. I think same situation. Same repeated question. Mass of A, displacement of A with respect to Planck plus displacement of the Planck. Mass of B, displacement of B with respect to Planck plus displacement of the Planck. Mass of Planck and displacement of Planck is 0. Right. Leave it. Now you see the next question. Try this seriously. See, there are series of such questions. Actually, series of such questions. 2 questions were there. A rope thrown over a pulley has a ladder with a man A on one. Already we have done this model previously. Ant rod case. Right. The man whose mass is M climbs upwards by delta R relative to the ladder and then stops, assuming the masses of the pulley and the rope to be negligible, pulley to be frictionless. Calculate the distance. Same question. See, we have done the same question. I'll just show you. This is the question. Same question. In the place of insect, assume man. In the place of rod, assume ladder. So in that case, what is the displacement of the center of mass we got? M into small m into L by 2 capital M. Same you need to do here. Then you may ask me why you have given this question. I doubt on your I doubt on your performance. That is the reason why I given. So same question. In that situation, what we have done? We took system 1, this part, system 1. System 1 is a ladder and man. And system 2, the counterweight. That's all. When no external force acts, center of mass will not displace. So in this case, displacement of the center of mass, you will write it as man. For example, we'll write this as M1, M2, M3, likewise. Okay, or you can make it as M times delta R. And actually, what is happening here in this case? Same here, like what we have done previously. We will write this as delta R plus Y plus M minus small m times, you said Y plus, and this goes down actually, M times minus Y capital M minus small m plus M plus capital. So in this case, what will happen is M delta R, My, here this part cancel. This part cancel. So finally, what you will get is M delta R by 2 capital M. And this is upwards. Already we have done the same question yesterday. Any doubts? I don't find any problem with this question. My next problem is with trouble. Their diagram was not at all. I'm not satisfied with the quality of the picture. This is the question which we are dealing about right now. Right. You have two ladders now. You have two ladders hanging. You can see left side a ladder, right side a ladder. But the issue is that, you see, right side total mass of the system is capital M. Left side also total mass of the system is capital M. Only difference is monkey 1 is a 2m mass, monkey 2 is m mass. The monkey of mass 2m moves up a distance L. One observation here. With respect to the ladder, the monkey of mass m moves up a distance L by 2 with respect to it, the ladder. Now the question we need to find very carefully. Very carefully. The first point that I would start up with is, see the diagram. Everyone see the diagram. Let us assume both ladders, both monkey, okay, as a system. Agreed? Any doubt? ఇందాక కూడా అదే చేసాం yesterday also. And rod, the counterweight, right? Second observation. When monkeys are at rest, system is balanced, which means no external force or net external force zero. Okay. Now change the color. These are thumb rules point. Now when a monkey starts moving up, this monkey pulls the respective ladder in the downward direction. And this increases the tension in the string. Last separate point. Why? Because today you will hear, tomorrow you may forget. Okay, hold on. When monkey start moving upwards, he pulls the respective ladder downward direction. In downward direction, due to which tension in string increases. This is another point of observation. Now there will be net external force acting on system. But in the game, that time they will rest. There is net external force acting on the system, and this causes, okay, center of mass of the system shifts upwards. Any doubt till this point? So now I am writing very clearly one by one. Displacement of ladder 1. Ladder 1 and already labeling is given here. Ladder 1. Displacement of the ladder 1. B Y upwards. Displacement of ladder 2. Because they are connected by a string. If this end of the string goes upwards by Y, this end of the string should come Y downwards. Now tell me please, have you followed this? Am I running fast? Am I dealing point wise? Right. Because this is a difficult question. You should spend some time on this. Right. During the same time, ఇక్కడ రాస్తాను, both the ladders are connected by same string. Right. Now ladder మీద వర్క్ చేసేసాను నేను. ఇప్పుడు ఎవరి మీద వర్క్ చేయాలి? మంకీస్ మీద చూడండి. మంకీస్ డయాగ్రామ్ లో చూడండి ఒకసారి. ఇప్పుడు నిన్న యాంట్ ఏం చెప్పాను నేను? ఫర్ ఎగ్జాంపుల్ ఉదాహరణకి యాంట్ వై షిఫ్ట్ అయ్యి ఉంటే కాదు, లేడర్ వై షిఫ్ట్ అయ్యి ఉంటే యాంట్ ఎల్ ప్లస్ వై షిఫ్ట్ అవుతుంది, అంతేగా. రైట్, ఐఎమ్ రైటింగ్ ద సేమ్. డిస్ప్లేస్మెంట్ ఆఫ్ monkey 1 will be L plus Y. Displacement of monkey 2 will be actually L by 2 minus Y. Why? That's given in the question. The monkey of mass M moves up a distance L by 2 with respect to the ladder. Right. Right. Areyar, I had the complete information now. What is delta YCM now? This is going to be a turning point stuff. So now general formula is what I am applying, like M1 delta Y1 plus M2 delta Y. 4 systems are there. M3 delta Y3 plus M4 delta Y4 divided by M1 plus M2 plus M3 plus M4. ఇంకొకటి తీసుకున్నాను, లేడర్ 1 అంటే లేడర్ M1, లేడర్ 1, రైట్. M2 2M ఇక్కడ రాసేస్తాను, అవాయిడ్ దిస్ థింగ్. M2 M3 ఇది M అయిపోయింది. M1 ఏముండాలి పైకి, సబ్స్టిట్యూషన్ చేసేస్తున్నా ఇప్పుడు. మరి Y ప్లస్ 2M L ప్లస్ Y ప్లస్ మళ్ళీ M మైనస్ M, దీని డిస్ప్లేస్మెంట్ మైనస్ ఎర్రదే మైనస్ Y. అరే లెఫ్ట్ లేడర్ ప్లస్ Y అయితే రైట్ సైడ్ లేడర్ మైనస్ Y ప్లస్ మంకీ. అరే మీకు తెలుసు కింద మొత్తం సమ్ చేస్తే వచ్చేది ఎంత, 4M. ఐఎమ్ నాట్ డూయింగ్ దిస్ స్టెప్ అగైన్. రైట్, అంతేగా. టోటల్ మాస్ 4M. నాన్న ఇదంతా చేస్తే నీకు వచ్చేది ఎంత అంటే పైన -2M ప్లస్ ఇక్కడైపోయింది. ఇదిగో ఇది అవుట్. ఎక్కడ 2M, డినామినేటర్ 2M ఎట్లా అవుతుంది, M మైనస్ 2M, రైట్, 2M కరెక్ట్, యు ఆర్ రైట్. రైట్, డన్ చేయండి. సో వాట్ ఈస్ దట్ యు ఆర్ గెటింగ్ ఇస్ -2M ప్లస్ 2M అవుట్ ప్లస్ M మైనస్ M అవుట్. ఇంకేం మిగిలినాయి నీకు, M ఇంటూ Y ప్లస్ 2ML మైనస్ M ఎందుకే మళ్ళీ ఇవన్నీ ఏంటో మొత్తం. ఇదిగో చూడండి, ఈ టర్మ్ పోయింది, ఈ టర్మ్ పోయింది, ఇక్కడ 2ML మిగిలింది, ఇక్కడ ML/2 ఉంది, అంతేగా. ఇంకేం మిగల యాక్చువల్. ఒకసారి చూడండి మీరే ఒకసారి. అరే 2ML ML/2 ఇంకేమైనా మిగిలినాయా, అప్పుడు ఏమవుతుంది 5ML/2 అవుతుంది అది. సో దిస్ ఈస్ టోటల్లీ 5ML/4 క్యాపిటల్ M. ప్లస్ వచ్చింది కాబట్టి అప్వర్డ్స్. Done. ఇంకేమైనా ఉందా క్వశ్చన్లో? ఎస్. ఆల్సో క్యాలిక్యులేట్ ద డిస్ప్లేస్మెంట్ ఆఫ్ ద ladder. ఇంకోటి ఉంది. ఆల్సో క్యాలిక్యులేట్ ద డిస్ప్లేస్మెంట్ ఆఫ్ ద ladder. దీనికి నిన్న కూడా ఇలాంటి టెక్నికే చేస్తాం, అది కూడా చేస్తాం మనం. ఐ జస్ట్ వాంట్ షో యూ దట్. ఇంకా ఎక్కడ చేస్తాం అది. డిస్ప్లేస్మెంట్ ఆఫ్ సిస్టమ్ 2 is displacement of system 1 వేసాం. సేమ్ కాపీ. ఓన్లీ డిఫరెన్స్ ఈస్ ది entities are different అంతే. So what I am writing is delta y center of mass system 1 is delta y center of mass system 2. Now what I am taking is a ladder first. M minus 2m plus 2m times L plus y divided by left hand side, the mass of the system is capital M, is equal to m minus m times minus y అంతేగా, plus m times L by 2 minus y by system is m. అంతేగా, రైట్ హ్యాండ్ సైడ్ కూడా m మాస్. అదంతా సాల్వ్ చేస్తే మీకు వచ్చేది y is equal to minus 3ml by 4m. So actually negative sign indicates the displacement of ladder is in downward direction. నేను ఎక్స్ప్లెనేషన్ కూడా ఇచ్చాను. Downward direction. Okay, done. Maximum models I have covered, but one ask is there which already you know, that I just want to cover it. Imagine smooth horizontal floor. This is some A block having mass M. This is B block having mass M. And this is experiencing a force F. They were connected by a spring K. Initially, both the blocks are at rest. Spring is relaxed. And this is a smooth floor. You need to find the maximum compression or maximum elongation in the spring. Now, what is the acceleration of center of mass of the system? External force by total mass of the system. This is the acceleration of center of mass. Now, if I am in C frame of reference, I will notice that this will experience a pseudo force, MACM. Yes or no? And a spring force. F spring, which is nothing but F by 2. Similarly, if you notice that this particular block, this is A actually, this is B actually. So this will experience spring force, applied force, and a pseudo force same F by 2. This is a pseudo force due to the acceleration of center of mass. Now I am assuming it has undergone a displacement x p, and this has undergone a displacement x a. Remember here, Fs is internal force. In C frame, Fs is internal force. So therefore, the net work done in this case is a change in Ke plus change in potential energy, because you are doing external. Now, F by 2, left side F by 2 does a work of XA. Right side is also net force, external force, remember, not internal. Is, remember, when the spring is maximum compressed, both the blocks will be at instantaneous rest. And this is half K XA plus XB square. This is a maximum elongation. Any doubt till this point? Now, therefore, this can be written as F by 2 times XA plus XB is half K XA plus XB whole square. 2 cancel. This is also cancel. Therefore, XA plus XB is simply F by K. Remember, same technique is also applicable even a different force acts on this and a different force acts on this. The first step 1 is find acceleration of center of mass. Step 2 is draw all the forces in the C frame of reference. Forget about the work done by the spring force because it's an internal force. Apply work energy theorem in C frame. That's all. So at the maximum elongation, change in kinetic energy is 0. That's all. Done. Okay. Right. I'm just stopping this.